So hi guys, good morning here. So here we have another problem that it's about sinusoidal modeling. So we have this table of temperatures in Athens, Lisbon, and Moscow. We want to do graphs, and we want to find the function or the equation that models this function. Okay, so the table shows the average monthly temperature for Athens, Lisbon, and Moscow. Graph the data to show that temperature is a function of time. Write the equations that model each function. Explain the differences in the amplitude and the vertical shift for each city. Okay, now let's look at the data here first. So this January, February, March, April. So if we look at Athens, we can see that the maximum values are June and July, right? And August. These three values are, while the lowest are December and January, which it makes sense, right? Athens, it's in the north atmosphere. Atmosphere. So that means that the summer it's June, July, August, and the winter is December and January. So actually, the same happens with Lisbon and Moscow because they are also on the north atmosphere. So now all of this graph will look like this. Right? Got summer in the middle and winter here at the edges. Okay, so let's look about that. Let's think about this now. I have for you. I'm sorry. I have for you. Let me show you something. Something I did. I took desmos. Okay, I took desmos, and what I did is I graphed those points. Okay. We're going to use a little bit of technology to do this, which is fine. So look at this. That's exactly what I have. Let me see if we can make this brighter. I think it's better like this, isn't it? Yes, it is. So this is these are the points. I'm gonna share you this under the video so you can use it also. So as you can see here, we have those points, the temperatures in Athens. That's what we are graphing. I don't know if we can see here the table that maybe. Oh my God, I'm sorry. Here, I'm not sure. I can see. No, I cannot. I just wanted, well, you can see the table of values if you click the link. Okay. What I just wanted to show you how these values are inside of Desmos. I plugged them, but that's fine. You just can see it on the link. Now, I would like to make this function here, which is this one, with all the parameters here. I would like you to fit with changing A, B, C, and D to fit this function in here. Okay, so if I change, for example, the amplitude, as you can see, the amplitude gets bigger, right? Can just change the amplitude and just put the value here that I want. I can also change B. If I change B, what it's changing is the period or the frequency, right? The period is getting bigger, or the frequency is getting smaller. Okay, they're related. And now I'm not sure I will be able to. Yes, well, C would be the vertical shift. Okay, sorry, the horizontal shift. You see how it's shifting, and then D would be actually. Let's stop this, otherwise it's too messy. D is the vertical shift. You see it's going up and down, right? So I would like to fit this in here, right? The data now, I see the data here. That's the data I have plugged in. Now I can see it. Okay, great. So I can start trying to modify these values, like the shift, right? I said, oh, the shift has to go up. So the vertical one, this has to go up. So I could come here, right, and just try to change the value, like equals maybe 20, right? So and try to fit this into here. Oh, it's then try to change the other values, but that's going to be a little bit too slow. And I want to show you a technique that might work a little bit faster. Okay, so here I have the data of Athens, and then the first thing I would like to know is what is the difference between the maximum value and the minimum value, right? So let's look at it. So this is each one of these squares is 10, 20. So that means that in between 10 and I have 1, 2, 3, 4, 5 squares. That means that each one of these squares is 2. So it's 10, 12, 14, 16, 18, 20, right? So that means that this is 12. The minimum value is 12. I don't know where to write it, maybe here, 12, the minimum value, while the maximum, this is 32, 33, right? Maximum value is 30, which I can see also from the data. And if I do the maximum value minus the minimum value, and I divide it over 2, I'm going to know where the axis is. So if I do 33 over 33 minus 12, this is how many? 21, am I right? Let's see. So 33 minus 12, it's 21 over 2. And then 20 over 2, that's going to be 10.5, right? 10.5 over 2. 10.5. As you can see, I do my calculations in my head, and then I just look at the calculator. If I'm right, that's good for your brain. So it helps your mental math. Okay. So now doing this, I know that from here to here, right, we have 21 degrees of difference, and the middle is 10.5. So that means that if I add 10.5 to this, which will be 22.5, right? That would be 22.5, 22 in here, 22.5, it's around here. Let's do 22 to make it easy, okay, 22. So that means that the axis that cuts this function in two, it's going to be actually here, in the middle, okay? So then how much is, if it is 22 and this is 33, how much is the amplitude more or less? It's 11, right? The amplitude more or less it's 11. So yeah, we have found A. For A is 11. So I think doing this math, it's in here, it's much easier. Now, how long does it take? How long does it take for a full cycle? How long does it take? Well, this is pretty obvious, right? Because how many months do we have until the year starts over and over? So we have a full cycle. How many months? So it's going to be 12 months, right? A full year, 12 months. So then that means that the period, it's 12. We're going to use radians now. From now on, we're going to use radians because it's what the scientists use. So that means that we're going to use this formula, 2 pi over t, the one we used before on the previous video. So 2 pi over 12, which is actually pi over 6, right? If we simplify, 12 over 2 is 6, so the 6 is going to go down here. Pi over 6. Now we have AB. Now C, the shift. If we want this to be, I think it's easier to trade this, to work on this as a negative cosine because it has been flipped, okay? But if you prefer to do the shift, then the shift will be like 1, 2, 3 months, 3 months and a half, right? So I'm gonna do both of them, so that's gonna be okay. So again, if you treat this as a horizontal shift, then it's 1, 2, 3, 4. Sorry, 1, 2, 3, 4. Oh yeah, 4.5. 4.5 months. So that means that it has been shifted to the right 4.5. Because it's to the right, it will have to be negative, as we said on the previous video. This will be negative 4.5. And then D, this, how much this has gone up, right? So this is going to be, the axis now it's 22. So it's 22. So now, doing all this, we can guess the formula. The formula then is going to be either 11 sine of pi over 6x minus 4.5 plus 22. Or we can also write y equals negative 11 cosine of pi over 6x, and then we don't need the horizontal shift, plus 22. Now let's check if this is right or not. Let's see. Sorry for this. I have to unlock the phone here. Okay. So let's see if that's right. So we said for D is 22. Then for C, we said it's going to be negative 4.5. Okay. Then for B, we said 2 pi over, no, pi over 6, I'm sorry, pi over 6. Come on. Pi over 6. Okay. And then the last one, oh, is it pi over 6 or negative pi over 6? Oh, no. The negative was the other one. Okay, sorry. So B is right, and then it looks like I've done something wrong here. And then A should be 11. It looks like the shift is wrong, right? Look at that, the shift is wrong. So I've done a mistake because it looks like this has been shifted, so it looks like I have a mistake on the shift. Oh, it's negative. That's what it's negative. Here we go. Okay. So look how easy it is to model if you really know what you're doing. Okay. How is this to model if you really know what you're doing? I think that this is enough. So you can proceed now to do the exercises for Lisbon and Moscow and just get the functions. And you can compare them and see, well, just looking at it, it looks like for Lisbon, as it doesn't get as hot, it's by the sea, by the ocean, Atlantic Ocean, it doesn't get as hot. And so the amplitude, it looks like the amplitude will be smaller, while in Moscow it looks like as the temperatures get much lower and it doesn't get as hot, that means that it actually is going to be shifted compared to Athens. It's going to be shifted downwards. Correct? I hope it helps. Have a nice day. Bye-bye.